Now we will speak something smaller. They make computer out of light. We will speak something smaller. If it has brain, the light has brain. They showed us. They're making computers out of it. We will search something still smaller. Look, this is one telling. The thunder exalts God with his praise, and the angels as well. When lightning happens, what is the tie of the thunderbolt and the angels? I think there is particles called neutrino. It's coming out of the lightning. This is the claim. Look, this is, you must know about this. This is very...
This particle was later dubbed neutrino, or little neutral one, by him.
From the atom, a small, very small, smaller than light particle comes out. It's called a neutrino, not neutron, a neutrino. We will speak about this particle. This is smaller than light, smaller than light. The light is the smallest thing. It's even smaller.
Rico Fermi in his theory of beta decay. 10 years later, Wang Gongchang proposed that the neutrino could be detected in a rare process known as beta capture. In the same nuclear reaction at the core of the sun.
Look, in the core of the sun, you know, two hydrogen atoms, and make fusion. How this fusion happen? When two hydrogen atoms in a 1,000,000 degrees, they fusion together, and what happens?
Neutrino.
A neutrino comes out. A neutrino comes out.
Neutrinos are emitted at a rate of 1 neutrino for every 1,000,000 photons. 90% of the neutrinos are released
just before a gamma ray came out.
in the first proton-proton.
Now it became helium, the hydrogen.
Reaction. The most energetic neutrinos are produced.
Now the helium argon making fusion, it gave up gamma rays.
Proton-proton 3-chain reactions, but are much less abundant as this reaction is far
It gave a neutrino again.
is probable.
This is the process of the sun.
The energy produced in the sun.
Look, listen here. This is the subject I'm speaking about. We told you when hydrogen fusion makes, neutrino comes out.
Photons take up to 500,000.
When this heat, hydrogen, is made helium, the light, so that it comes out from the core to outside, you know how much time it needs? 400,000 years. Because it's absorbed, emitted till it reaches here, it needs 400,000 years. Listen.
Years to get out of the sun, as they are constantly photons take up to 500,000 years to get out of the sun, as they are constantly intercepted, absorbed, and re-emitted. But neutrinos having no electric charge travel in a straight line from the core of the sun.
Look, when neutrinos are made, they go out directly. The light, it needs 500,000, 400,000 to go up. The neutrino, in 2 seconds, it gets out of the sun. We will speak about this.
They come out at the speed of light as soon as they are created. Hypothetically, about 3% of the total energy radiated by the sun is in the form of...
The 3% of the sun is emitted as neutrino. Did anybody knew about this? Look what's happening now.
Neutrino. The flux of solar neutrinos at the Earth's surface is on the order of 60 billion per square centimeter.
It's coming to us 60 billion particles per square centimeter. It's coming to us.
Per second. Unlike light, neutrinos travel through us, so about 1 trillion solar neutrinos pass through your thumb.
Inside your thumb, trillion millions of neutrinos passing. You know why it's passing? When the light hits the wall, it cannot pass. You know why? Because it's not small enough. It hits the neutrino. It's much smaller. It penetrates from stars to star. It doesn't hit anything. It's such small, very small. It penetrates everything. It goes through us. You know how they discovered neutrino? They catch 5 particles, 6 particles. Like this they catch it. And they test it. Nobody. These particles are everywhere, guys. More than the light is more, as much as the light. There is neutrino passing by. And where is its source? From the sun.
Every second. Neutrinos are the most abundant particle in the universe after photons.
Is the most abundant particle after the light, the neutrino. Nobody told me about this. We thought there is only light.
But how can we see that? How can we detect something that is not affected by the electromagnetic force and has no mass? How can we see a...
I told you we will speak about neutrinos. We will make claims now. Look, the devil, what it's telling to God. God told him, what prevented you prostrating when I command you to use it? Satan said, I am better than the man. I am better. You created me from fire, and you created from clay. I am created fire. What I understand? He's created in the sun. This is the neutrino. The angels are neutrino. This is my claim. It's clear. You created me from fire. What is the fire? Not fire like this. Fire of the sun. The light, it needs 400,000 to go out. Neutrino comes up. Now we will look the time. Look what they are telling. Look, this is very important here. The brain could be using quantum holographic principles in process electromagnetic signals not for our surrounding environment, but also could have access to higher frequency ranges, tau neutrino. Our brain there may be connection with the tau neutrino. Thus, our consciousness could be one of the few instruments we can use to make direct connection to the quantum neural network, the hologram. This means somebody is telling physicists the tau neutrino has something to do with the pictures we see. If we see angels, maybe we are seeing neutrinos. Neutrinos are angels. They give us pictures, hologram. You know, there is connection with the subconscious. Because the subconscious, there is S-place, I don't want to talk too much. The subconscious is light. And the light is made of neutrinos. The neutrinos makes hologram in our subconscious. My claim is they are the angels. But there is something, listen, they are angels, but not messenger angels. Angels. The messenger angels, I don't, it's difficult. Only angels.
What's the difference between angels and messengers?
It's a long story, I will tell you.
Can undergo this decay, since it requires that the isotope 1 beta decay from the original, being more unstable, making this simpler decay even more unlikely.
We will say something. We knew that everything, it has its antiparticle. We will see also if there is antiparticle. Is there angels, male and female? We will look this.
The nuclei for which this decay has been observed are extremely stable with lifetimes greater than the age of the universe. A third, as yet unobserved channel is neutrinoless double beta decay. For this decay to exist, the neutrinos must annihilate each other, a process which requires the neutrino to be its own antiparticle, and hence a distant type of matter to all other particles.
Coupled beta decay is a very rare decay process. So in some sense, it's very strange, but it has nothing special. It happens in a number of nuclei. What is very relevant is when this decay is produced without the emission of neutrinos. Why is that so? Because it marks the
These people are claiming, the scientists, that the neutrino, it's the same, it's antiparticle. It's one particle, it's again an antiparticle. It's not, they prove it, they tell. But the scientists, they don't agree.
Existence of a very peculiar property of the neutrino, the fact that the neutrino is its own antiparticle.
Neutrinos and antineutrinos in the standard model are supposed to be two different particles. If this process happens, neutrinos and antineutrinos are the same particle because the nucleus that decay, the neutrino exists inside the nucleus. It is an exchange between two particles.
In the nucleus, there is neutrino and antineutrino, they tell you. It must be one particle.
So the nucleus to make it possible this decay. This decay was foreseen by Majorana in I think 38 or maybe. Neutrino would be in this case also antineutrino. That is like matter to be also antimatter, talking to antimatter. And then in the universe you have only practically matter. So that might be an explanation why matter is so dominating in the universe.
We wanted to be able to make an experiment that could display a large mass and with very little thing. And there were a number of ideas.
Okay.